Welcome to day 4 of Intro to Object-Oriented Programming. Today we'll cover a very exciting topic, very exciting, polymorphism. Okay, this is one of the powerful things about object-oriented programming. We needed to learn inheritance in order to know how to do polymorphism. And here we go. I will warn you that I'm recording from home, so it's very likely that you'll hear a dog or a child or my wife or all three at the same time. Okay, today we want to be able to answer the question, what is polymorphism? Specifically, what is polymorphism in C#, and how can we achieve it using overloading and overriding? And then I've got a couple homework assignments for you to use polymorphism in our movie night application. So polymorphism comes from a Greek word, or it is a Greek word, meaning having multiple forms. So something that appears to be the same or is the same type, but it has a couple different forms. And I think these lovely pictures here really illustrate polymorphism. Here we have two things that are a cat. A Siamese cat is a cat. A Siberian tiger is a cat, right? But though they are the same type, they have a little bit different behavior, okay? A Siamese cat eats gently from a bowl, and a Siberian tiger does not. So in simple terms, you could just say that polymorphism means it has the same name, but the behavior is different, okay? Pause the video and repeat same name, different behavior 5 times. Okay, thank you. There are a couple ways to achieve polymorphism. We will talk about 2 of them today. We're going to talk about method overloading and method overriding. We're not going to talk about operator overloading or method hiding. I feel like those are advanced topics, but overloading and overriding is a way that we can achieve methods of the same name having different behavior. So very first, let's talk about overloading. A method is overloaded when, so the method has the same name, but it has different counts or different types of parameters, okay? Methods, so let's say I had a method called add, and that method accepted 2 ints. I would be overloading the method if I had a separate method called add that accepted 3 ints. And I can make as many overloaded methods as I want. I could have an add method that accepts an int array and so forth. Okay, and this allows you to do addition, but with many, let's say, different interfaces, right? So here's an example of overloading. In fact, it is add. You've got a doMath class, and you've got 3 methods called add. Now, formerly we were told that methods should have unique names in a class. Overloading is a way that we can break those rules. Okay, so the first add method takes 2 ints, int num1 and int num2. The second takes in a list of ints, and the third takes in 2 decimals. Okay, I can overload these methods. They have the same name, but accept a different parameter list. What I can't do is have the same name and same count and type of parameters, but different parameter names. Or in other words, I couldn't have another overloaded method called public int add int 1 and int 2, right? Because C# doesn't care about our parameter, or the compiler doesn't care about our parameter names. It cares about the count and the type. So let's do a little practice with that. I will pop open Visual Studio Code here. Okay, and I will create a new class. I'll create a new class called math. We'll create a new file called math.cs, and inside I'll create the math class. All right, here in the math class, I'm going to have lots of different operations. I will have a public int add, and maybe a public int subtract. Okay, just like our example, I can add together two numbers. So I will say int num1, int num2. Okay, and then I can simply return num1 plus num2. Same here, int num1, int num2. Okay, very good. I've got two methods. These methods are not overloaded. They're not overloaded because they have a different name. Remember, polymorphism is achieved by method overloading, and polymorphism means same name, different behavior. Okay, and so we don't meet one of those qualifiers there. We have different names. So I will now get polymorphic by putting together the public int add. And this time I want to take together, I want to take two lists of int. Okay, now I have two methods called add. One takes in two ints and the other takes in two lists of ints, right? So the behavior here has to be different. I have to handle these two variables differently than I handle these two lists or collections of variables. So maybe I'll say int sum is equal to 0. Then I'll come through and say for each int num in first set.
Hi.
Hello. Invader number 1 has been shooed away. Okay, where were we? We were creating the behavior of this second method here. All right, very good. So you can see here the behavior is extremely different for these two methods. Even though they have the same name, the behavior is different. So why would I want to do this? Why would I want to do polymorphism in C#? Okay, and the answer is flexibility. I want the code that I write to be very useful to people. So I want to give them the ability to add numbers in a variety of ways. Okay, if you think about it, there's a very important method in C# called toString. Okay, and toString is a polymorphic method. It takes in lots of different, or it has the same name but lots of different behaviors. So I'm going to pop open the Microsoft documentation here, and we will look at the toString method and see just exactly how useful it is. Doop-a-doop-a-doo, this is not what I'm looking for. How about we do this? C# toString currency. So as you know, you can use the toString method and just call toString, or now you can call the toString method and pass in this number format, and it will actually format currency just like this, okay? There are other options on toString, like making something uppercase or so forth, but my point is the toString method is polymorphic because there are lots of different ways that you can say, I want to change this thing to a string. So it's got the same name, toString, but lots of different behaviors. Okay, here are a couple more formats, so forth. Okay, very good. So that is method overloading. That is one way that we can achieve polymorphism in C#. Okay, just like methods, a constructor is a very special type of method, and you can overload constructors. So basically, you're giving the people using your code multiple ways to create your object. For example, we have this fighter class, okay? A fighter can just be created, and we don't set hit points. A fighter can be created, and we can specify the hit points. Or a fighter can be created, and we can specify hit points and bonus for the class of fighter that they are. Okay, so this is another overloading example. It's just this time we are overloading constructors, those special methods that we use to create objects. So let's do some of this. Here we are in our math class, and to overload constructors, very first, let me say that all classes by default in C# have a constructor that is a 0 parameter constructor, right? It's just something that's built into C#. The first time you create a constructor in your class, that default constructor is gone. So you will need to create the default constructor just like that. Basically, this is free code implemented in every class you'll ever create until you create another constructor, then this one goes away. Okay, here's a different constructor. I can say, I want a math class, but I want to specify 2 numbers to do all of the math operations on. Right, so maybe at that point I create 2 properties, public int first number, public int second number. And then in the constructor I'll set these numbers. Now, when someone calls the constructor that accepts 2 ints, we can add some extra overloaded methods here that doesn't accept any numbers and just operates on the numbers that were specified when we constructed the object. Okay, there you go. So this is an example of constructor overloading. Once again, same name. They both are the math constructor, so they are both called public math. One takes in a couple of ints, one doesn't take in any ints, right? Same name, different behavior. Okay, that is one way of overloading. We didn't need to know inheritance for that method, but this is the method of overloading, or polymorphism, that you need to know inheritance for, and it's called overriding, okay? Just like we had the same named methods in one class with different lists of parameters, we can actually have, in a parent-child relationship, a method that has the same name and the same parameter list. We do this overriding. We use 2 new keywords, virtual and override, and the behavior in the child actually replaces the inherited behavior from the parent. Okay, so this is how we make a Siamese cat and a Siberian tiger eat differently. And you can see here the example. We have a cat class, and then we have a tiger class and a Siamese class, okay? The tiger class and the Siamese class inherit from cat, so they get all of the behavior from cat, okay? A cat says, when it says make sound, it says meow. A tiger, when it makes sound, says roar, so it's different behavior. And a Siamese cat is very annoying, and it makes the sound of, it uses the base behavior or the parent behavior over and over and over and over again. Okay, so same name, make sound, has the same name in both the parent and the child class, but the behavior is different. And we can achieve this. You can see here the cat class uses the virtual keyword on this method. Okay, this is basically saying, I am a parent class, I have a method, and any child class can replace this behavior of this method by overriding or creating a method in the child class with the override keyword. And that's exactly what the tiger and the Siamese classes are doing. They are replacing the behavior of the parent make sound method with their own make sound method. So it's kind of like saying, when I override, I want to inherit all the behavior from the parent except this piece, okay? We still have access to the parent's behavior, as you can see in the Siamese class. We actually are using the base keyword. So when you are in a child class and you use the base keyword, you're actually saying, I want to use my parent's behavior. But we override the behavior by using the parent's behavior 4 times, rather than doing it than making the sound once. So let's do some more examples here. I'm going to go and create a file called account.cs. In account.cs, I'm going to create our public class account. Okay. Then I'm also going to say public class health. I'll call it HSA because I believe we have a health savings account class in this solution already. And then I will say public class RA. We are going to make HSA a child class of account. And we're going to make RA a child class of account. Okay. What is the shared data and behavior for accounts? Well, a very simple one is the public decimal balance. Okay, and then we'll go with a withdraw method. Okay, so we will say public decimal withdraw, and then we want to say decimal withdraw amount. Okay, and simply the account class is going to take the balance. We're going to say var withdrawn amount is equal to, no, we will just, balance is minus equals withdraw amount, and then we will return the new balance. Okay, so an account, a health savings account or an RA account, just say when someone wants to withdraw money from the RA account, let's go ahead and do it and reduce the balance, okay? We need to make this a virtual method because while this is the exact behavior for the health savings account, it is not the behavior for the reimbursement account only, okay? So I'm going to actually, well, I won't copy, I'll type it out. I will say public override decimal withdraw. In order to do overriding, we need to have the same parameter list. Okay, an RA has a, we'll call it a parent account balance. So this is the funding account for all of the reimbursement accounts. This is the big pool of money that holds everyone else's money. And we will say if parent account balance is greater than withdraw amount, then we will go ahead and do base.withdraw. Otherwise, we are not going to allow them to withdraw. Okay, so this is how we make the behavior different in the child class from the parent class. Reimbursement accounts have this extra rule saying if my funding account or the big account holding all of the money for all of the RAs at an employer or partner has enough funds, then we will allow you to withdraw. But if it doesn't, we're not going to allow you to withdraw. Okay, and that is an example of method overriding. I use the virtual keyword in the parent and the override keyword in the child. And because HSA class doesn't override the accounts withdraw method, when I create an HSA object and I call withdraw, I will simply be using this method. Okay, hopefully that makes sense, overriding. So when I was in college, the very first interview for internships that I got, I failed miserably at, so don't feel bad when you're interviewing for jobs or internships, but I'll always remember the questions that they asked me there. And one of the questions, they were trying to lead me towards showing them my knowledge of polymorphism by asking this question. They said, you are going to build some classes for the animal choir. Okay, in an animal choir, we have lots of different kinds of animals. We have horses and dogs and birds and alligators or whatever, okay? When the animal choir sings, I need to hear every animal sing. So basically, we're going to have a bunch of animal classes, and they're all going to have a sing method, right? But the behavior of the sing method should be different. So I'd like to code that up for you now. Okay, let's hop over to Visual Studio Code, and I'm going to create a new file, and I'm going to call it animal.cs. Okay, so very first, let's do it the hard way. Let's create a cat class, public class cat. Okay, this guy is going to have a method, public string meow, and it's going to return a string saying meow, 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 meow. Okay, let's continue doing it the hard way by creating a dog class. Until I don't like dogs. Okay, one more class to drive it home. We're doing this the hard way. Public class chirp. By chirp, I of course meant bird. Okay, very good. So I've got 3 classes. These classes are not in an inheritance relationship. They do a bark, a meow, and a chirp. Okay, I'm going to hop over to my program.cs here, and I'm going to delete all the code from the previous classes, courses, sessions. I don't know what you want to call it. All right, so I need to do the animal choir. If you remember, I need to create an animal choir and put animals in the animal choir. And when the animal choir sings, I need to go through and make each animal sing. Okay, so I actually need to add one more class, and I'm going to call this public class animal choir, and it needs to have a public void sing method. Okay, so I'm going to come back here and I'm going to say var choir is equal to new animal choir. I called it the sing method. Okay, so somehow I need to get an animal choir assembled. So an easy way to do that would be to give them a common type. I will do that now. So I've created this animal class. Okay, and now I can make each of these things an animal. So a cat is an animal, a dog is an animal, and a bird is an animal. Okay, very good. Now I can come back here to my program and I can start adding animals. Now that I do have an animal class, I actually need to create a collection of animals in our animal choir class. So let's do that now. Okay, because I'm working with a list, it needs to be initialized. So I'm going to add a constructor. I'm going to spell choir correctly. And then I will say choir members is equal to new list of animal. Okay, I'm now set up to go ahead and add animals to my choir. So I'm going to say choir.animals. I believe is what I called it. Choir members, pardon me. Choir.choir members.add, and we want to add a cat. Okay, I've created my animal choir, I've filled it up, and now I need to make it sing. So let's go back and make it sing. How are we going to do this? Okay, there is definitely a hard way to do this. Right? You remember we had our type of code and we could say, is this thing a type of a bird? Yes, it is. Okay, cast it to a bird and then call the sing method. Okay, but we can do better than this. This is why polymorphism is very powerful. Okay, we are instead going to go to the animal class and we are going to have first off, let's make this an abstract class because no one is ever going to create just a generic animal. We don't know what that is. And we're going to create an abstract method called make sound. Okay. If I were to build right now, I would get a bunch of errors saying, hey, The cat class, the dog class, and the bird class are supposed to implement a method called makeSound, but they don't. Okay, I will do that now. Actually, let's make this a virtual. Because it's virtual, we have a body, and we're going to return no sound because a generic animal makes no sound. And all we're going to do is we're going to return the meow method. Okay, I can basically copy this into all the rest of my classes here. Okay, and instead of calling the meow method, I'll call the bark method. And instead of the meow method, I'll call the chirp method. Great, now I'm set up to go through and get every animal and just tell it to make sound. And we'll write that out to the console. Okay. Okay, let's go to the terminal and let's actually make sure we're set up here in the program. Yes, we are. So we should go to .NET run. Oh boy, it looks like we already have a dog method in here somewhere. Yes, we do. Okay. This dog we're going to delete by dog. Okay, and it was also telling us that we didn't use the list. And Visual Studio Code isn't being very helpful. It should give us a using statement using system.collections. I'm going to pause while I look up the correct using statement. Okay, I'm back. I have now found system and system.collections.generic. Usually Visual Studio would just prompt me to add these using statements, but Visual Studio Code is a beast of a different color. Okay, now I'm set up to make sure and see if this runs. And I will go ahead and do it.
You're not going?
1 second, okay, honey, I'm still recording. Please hop out of here. A few more minutes. Hop out of here, okay?
Okay, a few more seconds.
Love you, bye.
5 more seconds.
Lydia, hop out now.
But I want to tell you.
Lydia, hop out of here. Working from home. Okay, as you can see, we have the animal choir now making sounds. So we got a meow, 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 woof, 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 tweet, tweet, tweet. Okay, and if I were to go back to my program and start adding more birds, my choir is now set up to handle as many members as I want. Got a couple more birds in there. I could easily come in here and start creating new animals. For example, an alligator. And as long as it overrides the make sound method, then I'm good. I could actually even just skip the alligator noise method. together. Come in here, and now I can add an alligator to my choir. Okay, behold the beauty of polymorphism. The same method, it's easy to know what my alligator needs to do in order to fit into the choir, but very different behavior. Okay, your homework for this time is to think about how we can use polymorphism in our movie night application. Okay, think about the rules that we may or may not choose to introduce. For example, let's say we had an RSVP cutoff date. If you RSVP before that cutoff date, then we're going to allow you to choose which showing you want to see. But if you RSVP after that date, we're not going to allow you which showing to see. We will assign you a showing based on what's left. Okay, so you can probably see some opportunity for polymorphism there. Another opportunity is, in the future, we may offer showings to our movie nights in some of the theaters in Price, right? We've got an office there in Price. So maybe, depending on where a team member is signing up, maybe they are offered showings in the Jordan Commons, or maybe they're offered showings in the King Cole Theaters in Price. Okay? So take some time, think about that, write up some code, some classes that use polymorphism to achieve these rules, or whatever rules you can see that you can apply polymorphism to in our movie night application, and send them my way. I'd love to see them. All right, that's all for today. Thank you.